Good morning, AP Calculus students today. So I would like to talk about sections, well this one it's 9.1 from that Rogowski textbook. So it's a separations by the variable, integration by separating the variable. So find the particular solutions of y equals f of x to the differential equation. So this one is coming out from that 2006 AP Calculus AB exam. So anytime that you see that the variable it's lining up with kind of like a rational form, so what we can do, we can always separate the variable. So what we can do here, so let's put it this way, it would just try to cross multiply. So we got dy times x, so that equals y plus 1 times dx. And then you want to group the y dy together. So what I can do, so I can divide both sides by y plus 1. And then on the other side, so we can divide it by x. Okay, so divided by y plus 1 at the same time divided by x. So what we found here, so this one is considered natural log of absolute value of y plus 1. And then on the other side here, it's considered natural log of absolute value of x. If you try to integrate both sides, plus constant c. So let's call this one c1. And now we definitely want to get rid of the natural log. So what we can do, we can take base e on both sides. So once you take base e both sides, so the left hand side, it turns out to be y plus 1. Okay, and then the right hand side, so that it just consider c2 times e to the power of x. Again, e to the power of the sum, so this one is considered e to the power of a plus b. It's the same thing as e to the power of a times e to the power of b. So e to the power of b, that's a brand new constant. So that one is called c2. So c2 e to the power of a. So for that general formula. And then over here, what we can do, we can solve for y. So isolate y by itself. So we got c2. So let's just call that general c, or just like a constant c there. So c e to the power of x minus 1. So then that would be the exponential model. And now another thing is that the condition of f of negative 1 equals 1. So using the initial condition, we can solve for c. So plug in 1 for y, and then we got c times e to the power of negative 1 minus 1. So basically this one is like c over e minus 1. So that equals 1. So add 1 on both sides. So we got 2 equals c over e, and then solve for c. So c equals 2e. And then for the equation, we just want to rewrite it in terms of all the constant and the variable. So this one is written as 2e times e to the power of x minus 1. In other words, it's like 2 times e to the power of x plus 1 minus 1. So that would be the original equation. Okay, so now let's take a look at that another one. So the domain of the solution to differential equations. So here's another example. Find the particular solutions with the differential equations. dy over dx equals 2 over root y. And the initial condition is 0, 9. So started off with cross multiplying. So dy times y to the power of 1/2. So that equals 2 times dx. And then integrate it both sides. So we got y to the power of 3/2 times 2/3 using the power rule on the left hand side. So that equals 2x plus c1. And now in order to solve for c1, before we solve for c1, so let's just simplify this equation a little bit. So what we found here, so is y to the power of 3/2. So that equals 2x plus c1 times 3/2. So 2 times 3/2, so we got 3 times x, which is 3x. And then c1 times 3/2, that's another c, so c2, like that. And now at this moment, you might be considering solving for c2 first by plugging the initial condition. We can certainly do that. Okay, so plug in 9 for y, so y to the power of 3/2. So that equals 3 times 0 plus c2. So c2, which is considered square root of 9 to the power of 3, so which is 27. So C2 equals 27, so that means the equation is written as y to the power of 3 half equals 3x plus 27. And then in order to get rid of that 3 half, both sides, so we multiply by the power with the reciprocals of the exponent, so which is y equals, it's equal to 3x plus 27 to the power of 2/3. Another way you can rewrite it, so this one is considered cube root of the quantity of 3x plus 27 squared. Same thing. Okay, so now let's see what else that we have. The domain of the solution to the differential equation. So here's another one. It's getting a little bit more complicated. So this one is an example from 1985 BC calculus exam. So 1985, that's a long time ago. Okay, so let's find out what that is. So find the general solution of the differential equation. So what we found here is dy over dx equals negative xy over natural log of y. For y, it's greater than 0. Well, because that's the domain of natural log function. So started off with cross multiplication. So we got dy times natural log of y. So that equals negative xy times dx. Again, we need to separate the variable. So x with dx, y with dy. So as you can see that whatever the y that we have, we always put it on the left hand side. And then for the x variable, we always push that to the right hand side. So divided by y on both sides. So basically this one we can apply the u substitutions for that natural log of y. So we got u equals natural log of y, so that means u prime equals 1 over y times dy. So using that the u substitution, we got integrals of u prime. And then for the right hand side, it's just the integrals of negative x dx. So integrals of u prime, so that would give you u squared over 2. Okay, that's c, we just want to add the on the other side right here. So negative x squared over 2 plus c1. And then u, we want to unpack that at this moment. So it's natural log of y, quantity squared over 2. So that equals negative x squared over 2 plus c1. And then in order to solve for c1, okay, so before we solve for c1, so let's see what else that we have. Find the solution that satisfies the condition of y equals e squared when x equals 0. Express the answer in the form of y equals f of x. So the initial condition we have right here is that when x equals 0, so y equals e squared. Okay, so another thing that we can do, so get rid of that 2 right here, or multiply by 2 on both sides. So we got natural log of y, quantity squared. So that equals negative x squared plus c2. Because 2 times c1, that's just a brand new constant. So solve for c2 here first. So plug in that y, so we got y equals e squared, so natural log of e squared, quantity squared. So that equals negative 0 squared plus c2. So solve for c2, so what we found here, so natural log of e squared, that's 2, 2 squared, that's 4. So c2 equals 4. And then what we got for the solution there, then that would be considered natural log of y, quantity squared, equals negative x squared plus 4. And then take the square root both sides. So we got natural log of y equals square root of negative x squared plus 4. And then take base e on both sides. So we got y equals e to the power of square root of negative x squared plus 4. So explain that y x equals 2 is not the domain of the solution. The reason why that cannot be the solution, because that once you plug in 0 for x here, once you plug in 2 here, you got negative 4. So negative 4 plus 4, which is 0, e to the power square root of 0, that's 0, e to the power of 0, that's 0. So if y equals 0, natural log of 0, which is considered undefined, because the natural log function is always going this way. So for the domain, so let's say that natural log of y equals x. So we just switch that x and y axis. So y must be greater than 0. So anything that's considered 0 or less than 0, which is considered undefined. So that's why x cannot be 2. Okay, so now here's the solution for the problem. Okay, so this one is going back to one of the differential equations. Is that the one that we did earlier? So this one looks like that's something else. It's just showing you the model. Okay, so the model for the way that people grading the AP tests. So separated variable, antiderivative, constant of integration, and then use initial conditions to find the value of c, and then after you solve for c, rewrite it. So 1 plus y equals 2 times absolute value of x, and then y equals 2 times absolute value of x minus 1, so showing the word simplifying. Get the domain as well, making sure that the domain satisfies the condition. Okay, so making sure that, so the way to separate a variable, the way to integrate it. So integrate it by separating the variable using power rule, exponential rule, or sometimes use substitution. But don't forget about the constant c at the end. Okay, so thank you for watching the video today. So let me know any questions that you have on the YouTube comments, and I'll see you guys next time. Take care.